Okay, that died on me. I don't know why. So to continue, we can see that lithium has on its last level, its second level, 1 electron, and sodium on its last energy level only has 1. And so if we drew potassium, rubidium, cesium, or francium all the way down, they would all just have 1 valence electron. Okay, so let's look at a couple of more just to get some more practice in on drawing these Bohr models. Okay, so let's look at hydrogen. I know we haven't done hydrogen yet, but let's look at hydrogen. Hydrogen, here we go. Hydrogen is atomic number 1. It has atomic mass of 1.008, so we're going to round it to 1. So our protons, we have 1. Our electrons, we have 1. Our neutrons, if we subtract 1 minus 1, we end up with 0. So we don't have any neutrons in the stable form of hydrogen. Hydrogen is on period 1, so we just need 1 energy level. We need our 1 proton and our 1 electron. So there is hydrogen, group 1, just like the lithium and the sodium Bohr model. So each of these all, if you can see, hydrogen, lithium, and sodium all have just that 1 valence electron. Okay, so valence electrons. One. It just has 1. So let's look at helium over here. I know we've already drawn it, but helium, it has atomic number of 2. It has the mass of 4.0026, so we're going to round it to 4. We have 2 positive charges. If we have 2 positive, we have 2 negative. And remember, in order to find neutrons, 4 minus 2 equals 2. So we have 2 neutrons, 2 of each. We are still on period 1, so we only have 1 energy level. We have 2 positive charges. We have 2 neutral charges, and we're going to have our 2 electrons. Now, if you remember right, when we wrote this down over here, I said group 18 has 8 valence electrons. Well, the thing about helium is there can only be 2 electrons on that first energy level, and it's full. So helium is the one element in group 18 that its valence electrons is only going to be 2. Okay, and it is full at 2. But helium is a noble gas. No more electrons can fit on that energy level. It just has that 1. It is non-reactive. It's inert. Okay, it will not react with anything else. All right, so let's see. We've done lithium. We know lithium has our 1 valence electron, so let's look at beryllium. Okay, beryllium, Be. Beryllium is atomic number 4. It has that mass of 9.012, so we're just going to round that to 9. Scoot this up a little bit. Right, so we have our protons, our electrons, and our neutrons. Now, when you are drawing your Bohr models, this is exactly how I want you to do it. I want you to identify how many protons, electrons, and neutrons you have, okay? So just like I'm doing it is exactly the way I want you to turn these in, to do them. Okay, so beryllium, when we find it, beryllium's right here. It's in period 2. Okay, so since it's in period 2, we know that it's going to have 2 energy levels. Okay, it has 2 energy levels. we have atomic number 4, so we have 4 protons. We have 4 positive, we have 4 negative. In order to find our neutrons, we take our atomic mass, subtract our atomic number, and we end up with 5. So we have 5 neutrons. So in the center, we have protons is equal to 4, neutrons is equal to 5, okay? We have 4 electrons that we have to put out. We know that only 2 can fit on that first energy level, and that leaves us 2 more to place. 1, 2. So there's beryllium. So it has valence electrons. I'm just going to put VE is equal to 2, the same as helium, but the difference between helium and beryllium is helium is actually full at 2, whereas beryllium is not full at 2. It's just it's a group number, that's as many as you can have. Okay, so we're going to look at boron. So boron is atomic number 5, and it has a mass of 10.8, so we're going to round that to 11. All right? So protons, electrons, and neutrons. So we have 5 protons, we have 5 electrons, and in order, remember, to get the neutrons, you take 11 minus 5, and so we have 6. 6 neutrons. Boron is in the same period as beryllium is. It's in period 2, so therefore we just need 2 energy levels. Okay, so I have 5 of those. I have 6. I need 5 electrons, so I fill my first energy level first. I have 2. I need 3 more. So 1, 2, 3. So my valence electrons equals 3. So group 13, as we said over here, group 13 has 3. So now if we skip over and let's look at argon. Okay, argon, Ar. Argon is atomic number 18. It is 39.9, so that makes it 40. Protons are 18. Electrons are going to be 18. Our neutrons, we'll have to figure it out, so 40 minus 18 will be 22. Okay, so I have 22 neutrons. Argon, we trace it over, is in period 3. So it's in period 3. That means I need 3 energy levels. So 1, whoops, I probably shouldn't have got that close. 2, put it in the middle, 3. So I have 3 energy levels that now I have to write extremely small in the middle. So my protons, I have 18. My neutrons, I have 22. Don't write that small. Makes it hard. Okay, we fill our first energy level first, and there's only going to be 2. So 1, 2. My second energy level can hold up to 8. We're going to need all 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 is 10. So I need 8 more. They're going to go on my last energy level. So 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 on the first, I have 8 on the second, and I have 8 on the third. So 2 plus 8 is 10, plus 8 is 18. I have all of my electrons. Valence electrons, I have 2, 4, 6, 8. I have 8. Okay, remember we said the maximum number of valence electrons you can have are 8. Argon, it's in group 18. all of group 18, these are your noble gases. Their valence level is full, and so they're non-reactive, and they're going to have that maximum number of valence electrons. Okay, there's one more thing I wanted to talk to you about, and that's called an isotope. Okay, isotopes. Isotopes. And as we said, or you've noticed, that all of these have the atomic masses are a decimal point, unless you get down to these here that it's in the parentheses, and those are mainly man-made. Okay, and so they don't, there's only one form of that atom. And so an isotope is just the different forms of the same atom. So isotopes are different forms of the same element that contain equal numbers of protons but different numbers of neutrons. Okay, so in other words, the atomic masses for each will be different. Okay, so the atomic mass of these is the average of all the isotopes of that particular element. And that's why it's a decimal point. And so the elements on the periodic table, that's the most stable version of that. And so I'm just going to look at hydrogen. So let's look at hydrogen. There's 3 forms of hydrogen. So we have the one that's on the periodic table. So we're going to put H. It's atomic number 1 and atomic mass of 1. I'm going to scoot over, have H, atomic number of 1 because it's still hydrogen, but I have atomic mass of 2. And then our last one, hydrogen, atomic number is not going to change, but my atomic mass is going to change. Okay, so these are the 3 forms of hydrogen. So we're going to figure out we have protons, electrons, and neutrons. Our protons, our electrons, and our neutrons. And one more time. And neutrons. Okay, so first model, I have 1 proton, I have 1 electron, 1 minus 1 is 0, I have 0 neutrons. The second version, 1 proton, 1 electron, 2 minus 1 is 1. I have a neutron in this one. Third version, still 1 proton, 1 electron, and now I have 2 neutrons. So as you can see, the only thing that changed is the number of neutrons. My protons and electrons stayed exactly the same. So the only thing that's different is that atomic mass, and that's because of the different numbers of neutrons. And so if you drew the Bohr models, they would look like this. They're all, it's, excuse me, period 1, so I just need 1 circle. Okay, so I have 1 proton, 1 proton, 1 proton in each of them. I have 1 electron here, no neutrons. I have 1 electron, I have 1 neutron. I have my 1 electron, but this one I need 2 neutrons. So that would be the Bohr model of each of those. Okay, so that's an isotope, and hopefully that explains why it is a decimal point, is that each of these actually exists in more than one form. They all have the same number of protons, they have the same number of electrons, but the neutrons will be different within the isotopes. And so it is an average, the mass is an average, And the ones that occur on the periodic table are the most stable forms of that particular isotope of the atom. Okay, so that's what that is. Now, what I want you to do, this is your assignment. I want you to draw the Bohr models, and we've done a few. That doesn't mean you can skip them just because we've done them. I want you to try and draw. Okay, draw the Bohr models 1 through 10. That's it, just the first 10. That's all you have to do. I could do 1 through 15, but I'm just going to do 1 through 10. And all of this information, I want to see it. Okay, so when this is graded, should see all of this information on there. So we're going to try 1 through 10 at first, and then we'll expand from there. So that's the end of your notes. I know these were really long. Sorry about that.